This video is part of a series. It's heavy in scientific terminology and may expect familiarity with previous videos. If you're confused, please watch the rest of the playlist up until this point, or check out my genetics terminology document, both of which are linked in the description. Thanks! So, dogs have like 100 million things that could cause them to be white in all kinds of interesting and complicated patterns. I've decided to lump them all together into a single video, except for Merle, which was the last video. I kept Merle on its own to highlight the ethics of it, but also because I could figure out how to isolate the explanation. A lot of what I'm going to talk about here, though, plays into itself in a way that I think really ought to be a single video. So here you go. Here's all the non-Merle true white dogs that I know about, plus a bonus at the end. The S locus stands for white spotting. This is the typical wide range of white patterns you'd see in most dogs. This is a form of leucism, which means that in embryonic development, pigment-producing cells aren't going where they need to go, leaving parts of the dog unpigmented. This lack of pigmentation is considered true white, unlike very light, white-looking red dogs, who are fake white. Dogs who have both pigmented hairs and leucistic hairs are said to be piebald. SP is the allele responsible for white spotting. Meanwhile, the S allele is the no white allele that doesn't code for any leucism at all. SP is codominant with S. Heterozygous SSP dogs tend to have small white markings, which can vary a lot, anything from a white trim to a full tuxedo-esque pattern. Homozygous SPSP allows for much higher markings, going up completely over the head and sometimes covering most or all of the dog. The exact patterns for both hetero and homozygous dogs here are polygenetically inherited, almost certainly partially developmental, and can take on a wide variety of different shapes. Though generally, like most mammals, white spreads from the bottom up, covering the belly, neck, and paws first, before the spine and ears. The head is the last thing to be covered by white, but if a lot of it is covered, the dog may be deaf. If there's a just turn the dog fully leucistic white allele, we don't know about it. It seems that any given all-white dog is just an SPSP homozygote, or a red dog masquerading as white via a ton of dilution alleles. Or they're albino, but we'll talk about albino later. There's kind of another piebald-causing allele here called Irish spotting, represented by SI. And the reason I say kind of is because it's probably not actually on the S locus. One of my sources calls SI a, quote, placeholder until we figure out what Irish spotting is actually caused by. Breeders are just kind of pretending it's on the S locus until we know what's going on, despite being pretty sure that it's not. Weird, but okay. Unlike SP, which has a lot of variability, SI always causes a very specific pattern of white, although it can be higher or lower. Irish spotting makes the legs, tail tip, chest, neck, and muzzle white, with a white blaze up the nose too. It can also go all the way around the neck like a white collar. This is also sometimes called Boston or mantle. It's recessive, ? Breeding two Irish spotted dogs together always produces more Irish spotted dogs, which suggests that it's fully recessive. I hope that someone researches Irish spotting because I'd love to find out what it actually is. As a side note, SP is fully capable of mimicking the Irish spotting pattern, and they can be indistinguishable from appearance alone. Most dogs who look like they have the Irish spotting pattern do not have the Irish spotting genes. They're just SSP or SPSP. There's also another piebald affecting gene, but we know almost nothing about it. They haven't found it. It has no named allele yet that I can find, and research is ongoing. The phenotype it causes is called Whitehead, wherein white starts from the front of the dog working back instead of working from the bottom up. A normal piebald dog's head is the last thing to be covered, but a whitehead dog's head is covered first. Like before, if the head is fully white, the dog may also be deaf. Whitehead is described as, quote, incompletely dominant. I assume they mean with S. So a hetero... hold on, I need an allele name for this thing. Let's just call it SH today. A heterozygous SSH dog will have less white than a homozygous SHSH dog. I have no idea what the rest of its dominance is, nor how it interacts with SP, much less SI. Sorry. Piebald has two modifiers on the same locus that do similar but distinct things. We don't know what their interactions or dominance are in relation to each other, but we do know they're both dominant, or possibly incompletely dominant, over the normal doesn't do anything allele, little t. This is the T locus, by the way. Capital T causes ticking, and TR causes Roan. Roan? I've heard both. In both cases, the dogs are born with their white normally distributed, as if nothing is weird at all. Then, as the dog grows up, pigment starts coming back. In Roaning, pigment overtakes, causing a kind of salt and pepper TV static look. In black long hairs, the pigmented and unpigmented hairs can blur together, making a kind of bluish look. This is not dilution or merle. It's just the result of alternating pigmented and unpigmented hairs. Kind of like dotting red really tiny on a white background to make something that looks pink from far away. The shape of the white remains. If the dog had a big pigmented spot on their back when they were born, that spot stays fully pigmented. It's just the piebald white markings that get salt and peppered. In ticking, pigment also returns, but this time in the form of small spots. Ticking creates little holes in the piebald. It seems to favor the face and legs, causing more spots there than anywhere else, and sometimes only causing spots there. Just like with roaning, the shape remains. It is possible for a dog to show both ticking and roaning, but we don't know entirely how this works. For fictional purposes, I'd call capital T and TR co-dominant with each other. They're both dominant over little t. Dalmatians are homozygous SPSP dogs who've been selectively bred for extreme ticking. There's also an unknown modifier that Dalmatians have that helps their spots be more, Dalmatian-like. Whatever that modifier is, it also causes kidney problems. Being a phenotype of homozygous SPSP, where the white covers their entire head, Dalmatians are frequently deaf. Fun fact, by the way, this means Dalmatians can hypothetically be any color, not just black, but blue, liver, Isabella, and even red, which is called a lemon Dalmatian. Their spots are more or less just giving us a window into what's going on underneath their piebalding. If they have a pattern with mixed red and eumelanin, you could even get spots of both colors. All forms of piebald open up the possibility of blue eyes, which is more likely at higher whites that reach the face. This is because blue eyes don't come from a blue pigment, but rather, blue is the color that eyes are underneath pigment. So by getting rid of that pigment, we can see the blue underneath. This is also true for pink noses. Dogs with a lot of piebald might have a pink splotch or two on their nose, which is called butterfly. It can be hard to see on a liver or Isabella dog, though. More rarely, a dog's nose may be fully pink if totally surrounded by white. Similar to merle, the lack of pigment leaves their skin vulnerable to the sun, so there's an increased risk of sunburn and skin cancer. I don't normally include genes that are too breed-specific or rare, but y'all know I get excited about new genes, so I have to take a minute to talk about Panda. It's a brand new mutation that showed up in the year 2000, and it's currently exclusive to German Shepherds. Right now it seems to be on its own locus, which is being called P. Panda dogs have white markings on their belly, chest, and muzzle, around their neck, the tip of their tail, and sometimes the face, or on the forehead, or in the in-between the ears area. No homozygotes have been observed, meaning this gene is most likely embryonic lethal. So capital P heterozygotes display the panda pattern. Capital P homozygotes die in the womb and are never born. How does it interact with any of the S locus, or whatever Irish white spotting is? Hope we find out one day. Leucism is not the only kind of true white. There's also albinism, which works a bit differently. It has more to do with pigment-producing cells not doing their jobs, rather than not showing up to work at all. Now, usually in mammals, albinism is on the C locus, but dogs are weird. The only known locus for albinism in dogs is called SLC45A2 by scientists, and known as Z by dog breeders. This is the same locus responsible for cremello in horses, and mutations on the same locus in humans are also known to cause albinism. Albinism, of course, makes a dog fully white, although there may be some faint pigment, like an off yellow, which you'll often see in a lot of albino animals. It's epistatic to absolutely everything else. Everything. All of the colors, completely. And it cannot be modified by ticked or Roan. Those only work on leucism, not albinism. In stripping the dog of pigment, it also invariably turns the skin, including the nose, pink, and turns the eyes blue. They can often have a kind of pinkishness to them, especially in the pupils. Due to the extreme lack of pigment, their eyes are sun-sensitive. That's true of any blue eyes, but especially albino. They, of course, also have that increased risk of sunburn and skin cancer that comes with exposed, no melanin having pink skin. Strictly speaking, I can't find any letters for the allele, but you should know that dog breeders call heterozygous albino-carrying dogs Z-factored, which is badass! Personally, I just use capital Z for non-albino and little z for albino. Or maybe following the really cool way that dog breeders name alleles, Z for non-albino and ZA for albino. I don't know, make your own. There are other genes that cause albinism in dogs, like the one scientists call 493D. But Z is the only one with the closest thing to a letter name that I could find, and they all seem to work the same way, so just pretend it's one gene. Now, normally, I would save this next thing for, like, a final here's all the weird extra genes that don't fit anywhere else video, but it's technically a form of albino, even if it doesn't cause white, so I'll cover it here. There has been one, well, technically two, but only one I have colored photos of, Himalayan dog. Himalayan is a common phenotype in domestic mammals. It's found in cats, mice, rats, rabbits, and now we have a Himalayan dog. It's a temperature-sensitive form of albinism that causes the warmer areas of the dog, where the organs are, to get lighter via pigment-producing melanocytes losing function, while the colder parts of the dog, the extremities like the nose, ears, tail, and feet, to stay pigmented. His eyes are a kind of pinkish blue with reddish pupils, just like a normal Z locus albino. Unfortunately, this guy is infertile. Not neutered, infertile. He just naturally can't produce offspring. We don't know if this is an unrelated issue, or if his Himalayan mutation is somehow also causing the infertility. I hope it's the former, because I'd love to see this mutation bred, so we can learn more about how it works. Practice squares time! For those doing multi-loci Punnett squares, have fun with the S and T loci. For the rest of you, here's your first square. Tell me the parents and their offspring. Hell yeah! One parent has low white, and the other parent has high white. Puppies have a 50% chance of each. Now for the T locus. Remember, we don't know for sure in real life, but for our purposes here, let's pretend that the alleles behind ticking and roaning are co-dominant with each other. I'll help you out this time by giving you the parents. The capital T TR heterozygote has both ticking and roaning. The TR little t heterozygote only has roaning. Bit messy. Let's break it down and see if you got it. There's a 25% chance of the puppy expressing both roaning and ticking, because when both alleles are present, they both express. Probably. For our purposes, they do. There's also a 25% chance of the puppy only expressing ticking. But there's a 50% chance of the puppy only expressing roaning. This is because little t is fully recessive to TR, so both the TR little t result and the TR-TR result, despite being different genotypes, produce identical phenotypes. If you got it, great job. If not, it's okay. This stuff's hard, and you're here to learn. Getting things wrong is part of that. Of course, since T is a modifier locus, if either parent doesn't have any piebalding, their T locus will be invisible. So, for example, if the capital T TR parent doesn't have any white, then it wouldn't look like either parent has any ticking, so a ticked puppy would come as a total surprise. Of course, that parent does have ticking. Modifiers are just invisible without the thing they modify. That was the last color video for the series. The next one will instead cover hair types. I'll see you there.